Today we have a great lineup. Really excited, as always, to have Ben Snyder, one of my coworkers, or yeah, my and Antje's coworkers. Ben is great. He's an applied scientist here at AWS, and that's a very coveted title, by the way. These are folks that are not only good with data science and neural networks and the science behind things, but they're also very, very practical, very hands-on. They understand scale. They understand the modern tooling. Ben, we had reached out to. I was actually working with Ben on a customer project, customer situation, and I said, "Hey, you seem to know quite a lot about Mixtral and SLURM, so would you mind coming on board?" Speaking at our meetup here publicly. So he's going to speak about Mixtral, which is Mixture of Experts model. I'll explain it here in a bit. He's also going to describe SLURM. SLURM is, which I have a slide on SLURM as well too. So it's think of it like a job resource manager that's really popular in the HPC world. And we're seeing a lot of customers that are starting to adopt it or either come from, a research lab where they were using it in an academic setting or in a research setting, and now going to productionize these massive models. Now, Mixtral is not actually massive, but training, getting all this data in, we're seeing clusters, 2,000 node clusters. These are, the new H100s, the A100 80 gig instances. So we're seeing very large clusters. So that'll be really exciting. And then Antje, you're going to talk about instruction fine-tuning and some of the principles behind it, and walk through parts of our book, including the images that we spent a lot of time on, right?
That's right.
Okay. Cool. And then I'm gonna finish off with continued pre-training, which is sort of like fine-tuning, but not really as structured. Continued pre-training, you just keep feeding in similar documents to what you use during the actual pre-training phase. And so I'll talk about some of the differences and show an example where we actually feed our PDF, our book PDF, in to our like Amazon Titan model through Bedrock. And I have a notebook, and all of the GitHub examples that you see today are available at this link down here. So there's nothing hidden here. And here's a link to our YouTube. We'll be posting this on the YouTube in a bit. Here's a link to the book. Antje, do you want to talk a second about the community AWS?
Yes, so we have a community space here, community AWS, and specifically for generative AI. So if you're interested to learn about the latest really in the space of Gen AI, developer to developer. So my team at AWS, the developer relations team, and as well the community right here in this space about, current topics they're working on, technologies they're working on, use cases. So it's not just AWS writing here, but it's also people from the community writing. So if you want to engage more and are interested in exchanging thoughts, maybe even contributing, writing a blog post, if you're working on an exciting project in the space, feel free to check it out. We also do have links here to videos. We do have links to online courses if you want to learn more. One course here on the right where Chris is just scrolling through the Generative AI with Large Language Models course. And we do also just recently, we have launched a new course on deeplearning.ai on Amazon Bedrock. So the generative AI service we have that makes a lot of foundation models accessible through a single API. So if you're interested in that one, also check it out.
Excellent. Okay. And I guess just a quick plug here for the book. So, here's, we were #1 in quite a lot of these categories, was really excited about this. And if you are a reader of the book, please go add a rating on there. It really does help through the Amazon rating system to keep things going there. Special thanks to many of our reviewers, by the way. We had, some pretty heavy duty folks within AWS and outside of AWS, including Snowflake and Meta, and some of our our AWS ML heroes as well. Okay, real quick, high level, brief overview of Mixtral. Mixtral comes from a company called Mistral.ai. There's their logo there. And Mixtral is a mixture of experts model, often called MoE. If you're at the coffee shop, you know, in Palo Alto or San Jose or up in San Francisco, you just say MoE. Everybody knows what you're talking about, including baristas and you know, folks kind of just lingering around. Mixtral is actually a 45 billion parameter model, and it has 7 billion expert models. So what you'll start seeing in the MoE world is this, you know, 8 by 7 or something by something. So this means, you know, and of course these are just conventions, naming conventions, but this is 8 experts, each of them 7. Now, some of you might be saying, well, wait a minute, 8 times 7 does not equal 45. And that's because because these experts, so there are like actually many parameters that are shared between the experts. And in fact, the way that this works is each of these experts is a, you know, 7 billion, but there's also extra parameters that are learned during the training process to figure out which expert to actually route your prompt, your, you know, question to the model, where to route that particular input to. Okay, so they're called gating weights typically, usually part of what's called a router. Now, this is a router that's actually integrated into the model itself. So it's not your, you know, classic sort of web server router kind of thing, right? So this is not web service stuff. This is actually within your deep learning model. And these weights that make up the router are actually learned and back propagated during the training process. Okay, so while, you know, 7 times 8 is not 45, just know that you now have to start looking at like different things here. So you see, okay, each expert is 7 billion. The total model itself is 45 billion. The other thing to note with these mixture of expert models is that when you go to perform the inference, it actually only uses 14 billion parameters during inference. Okay, so stepping back a sec, what this means is we are only going through, you know, approximately 7 billion for these gating weights, and then another 7 billion through the experts is like one way to look at it. Okay, so just know that even though this is a 45 billion parameter model, during inference time, it acts like a 14 billion parameter model. And that's very significant because that means during the forward pass, when I'm actually, you know, right, like running my actual prompts through this model and trying to generate tokens, it acts like a much smaller model than it appears to be. Okay, so also some of the, you know, characteristics here are that Mixtral 8.7b actually outperforms GPT-3.5. Now we know GPT-3.5 is not the latest from OpenAI, but you know, is a worthy benchmark to call out since this was the standard for quite some time. It also outperforms Llama 2 70 billion. So this actually outperforms a model much, much larger. And then keep in mind that when you're actually talking about inference, you're comparing 70 billion, which takes, you know, could take 10 seconds to go through and actually, you know, perform the inference versus a 14 billion parameter model during inference time. Okay, so I can't stress that enough. Also handles context of 32,000 tokens. I'm sure this will get larger and larger as the newer variants of the Mixtral model are released. Here's a quick sample. This is actually from our repo here. This is using the instruct fine-tunes. Antje is going to talk about that later, what that means. Instruction fine-tune variant of Mixtral 8.7b, and just gives you, you know, a quick way to show how to do this with SageMaker using our first-class Hugging Face integration. Okay. So quick mention on SLURM. So Ben's going to talk more about this. He's going to dive into the details and show you, SBatch and SRun, and give you a hint at really, how this is all working. But just know that SLURM stands for Simple Linux Utility for Resource Management. That's quite the mouthful. Think of it like really it's a cluster workload manager. That's really what SLURM comes down to. And it's very popular in the HPC world. If you're not dialed into the HPC world, this might seem completely foreign. A lot of folks like to compare SLURM to Kubernetes. Yes, interestingly enough, there's actually a project that should be open sourced, hopefully early this year, by a company called CoreWeave that's called SLURM on Kubernetes. And so think of it like using the best of Kubernetes and then using the SLURM interface. Now, what Ben is going to show you today is how to actually use SLURM on a new service from SageMaker, from like Amazon SageMaker, called HyperPod, that was released back at reInvent in December. And so he'll show you how to actually use SLURM and show you how to actually train a Mixtral model, and I believe also potentially Llama 2 as well if we have time. So he'll go into the details there. But yeah, just like any cluster workload manager, this is going to allocate access to resources. Of course, resources in this case is the compute nodes, and these could be, the like H100 clusters, could be the A100 clusters, whatever you decide to provision that is suitable for your workload. SLURM also provides you a framework and a set of commands to manage across all of these nodes in your cluster. Again, you can have 2,000 nodes in the cluster, which 2,000 times 8 GPUs per node could be, 16,000 GPUs that you're managing. And can go beyond that as well too. Yeah, 2,000 was just a number pops into my head. And SLURM gives you a way to actually monitor that work and then manage the queue of pending work. So think of being able to submit jobs shared by many people within your organization. Okay, and then real quick, also, Antje and I, after Ben gives his talk, Antje and I will come in and discuss, how to do instruction fine-tuning. Also part of this, continued pre-training, touch a little bit on the evaluation. And then I believe next month, Antje, we are doing human feedback, and that's going to be RLHF. We'll talk about DPO as well too, direct preference optimization, and then the month after we'll cover optimization and model deployment, and continue on through the generative AI lifecycle. So I think, Antje, is Ben ready to go?
Yes, we have Ben back on the line. You just need to promote him to co-host so you can share the video again.
Got it. Oh, that's right. I have to do that, don't I? Okay.
Yeah, it's just the video settings otherwise.
And Ben, if you could just do a real quick intro. I think while you were gone, I had already explained who you were and that we worked together and things like that. So take it away, Ben.
Yep. All right. Let me see if I got. Okay. Let me just make sure if my screen's showing up for everyone.
Yes, we can see the browser. Yeah.
Okay. Managed to tame my laptop and make it work nice with Zoom. All right. I'm Ben. I think Chris gave me a brief introduction there, but I'm an applied scientist with AWS working on HyperPod. I'm just going to go through today about some of our work on HyperPod and show specifically some work I've been doing recently with getting Mixtral up and running on that system. And this is really just kind of showing a general workflow, what it's like to build a model for a SLURM system. Just to start out here, for anyone who wants to dig into this more, there's a QR code and a link at the top on my screen right now that will give you a bunch of examples. It doesn't have some of the latest stuff I've done here in it. We're working on getting that in right now, but it has the basic FSDP examples I'm going to be showing, and I'll go over what FSDP is in just a minute. So just a brief intro on SLURM. I know Chris already mentioned this, but it's the simple Linux utility for resource management. And it is basically the most straightforward way to run a large computing cluster. It's used on the majority of the world's top 500 supercomputers. And the basic idea is it manages access for all different users on that system to the different nodes. So if you think about, the Summit or Frontier computers, they have thousands of machines on them. And basically what it's doing is that as those systems are running, it's usually not just one job running on all those nodes. There's usually a whole bunch of different users that are coming in and running, somebody gets access to run some research job on 100 nodes for a few days, right? And somebody else at the same time is running a different job that only takes 32 nodes. And so the SLURM system allows, basically handles the access to the different nodes for different users and places their jobs on the machine. And in connection with that, SageMaker HyperPod is a way to quickly and easily set up a sort of semi-managed system. It comes with certain features on top of SLURM for basically running a SLURM type system on AWS. And this allows you to quickly bring up clusters that can be a range of different GPU types. So they can be anything from V100s, A100s, the H100s, also supports Trainium chips, so you can design different clusters to match your workflow and quickly bring those up in a matter of minutes. The basic structure, I have just a diagram here showing the HyperPod setup, and this is basically the same setup you would have for any SLURM cluster. You'll have some group of worker nodes. Typically, that's going to be anywhere from dozens to hundreds. For today, we're just going to do 2 just to show a very simple example. Connected to that will be a controller node, and that controller node is what's actually responsible for the SLURM, what we call the SLURM control daemon. That actually manages access to those worker nodes. And then finally, there's a login node, and this is basically where users are going to log in. They're going to have access to that SLURM controller through that login node, but they can also use that login node as kind of their workspace. And then connected to all this is actually a shared file system. In this case, we're going to use FSX because it's fairly high performance. And that connects to all the nodes in the cluster. So all the nodes can see the same files at the same time. And then finally, there's S3. And S3 manages the configuration for the cluster, and also is can also stream data to the cluster. For today, we'll just do the configuration part of that. So what I'm going to do is I'm first just going to jump in and show some basic SLURM commands, kind of show what SLURM is doing. And then we're going to take a step back from there and then look at the actual cluster setup. And then finally go through the process of both setting up a job, kind of the interactive portion of designing a training job, and then actually launching it on a SLURM cluster on multiple nodes. So let me jump over to my terminal. So I'm using Jupyter Lab in this case. And this Jupyter Lab is actually running on a login node on a cluster right now that has 2 H100 2 P5 instances. So if I run sinfo, let me actually zoom in a little bit here. If I run sinfo, you'll see I get 2 nodes and the IP addresses for those nodes. And okay, oh, I still have a job running. Let me just just a couple of commands here. I'll just go through. So sinfo actually shows you the basic info about what nodes are connected on your SLURM cluster. SQ shows you what jobs are running. In this case, I actually have a job running. I was running a little over 1,000 jobs over the weekend to do some hyperparameter tuning. So I'm actually just going to cancel that job right now, which you can do by scancel 1052. And then if I run SQ again, you'll see it's now showing CG, which just means it's closing down that job. So those are the main commands just to get the info. To actually run jobs, what SLURM is going to do is it's going to for each user on the cluster, it's going to take a request for an allocation and see if those nodes are available. So for example, I can run salloc-n2, and what that's saying basically, I'm sending a command to SLURM to say, can I get 2 nodes to work on? From this cluster, can you give me 2 nodes to use? And it's now granted that allocation. And so if I do SQ, it'll see I have an interactive allocation of 2 nodes, and it's job 1053, right? If I exit out of that, it'll say relinquishing job. So that's basically, so that gives you the allocation. You can then run commands on that. So let me just get one more here. And what that's going to do is actually very simple, what it's doing, because behind the scenes, it's just setting a set of environment variables in your terminal that says, if you try to go launch a job or you try to run a command, it knows the IP addresses of those nodes. So if I just print out my environment variables, you'll see like SLURM job node list is now set to those 2 nodes, right? Now what I'm going to do is I'm going to open up another terminal, and I'm going to try to run that command again. And you'll see it says queued waiting for resources. And that's because basically I sent the command to SLURM saying, hey, can I get 2 nodes? But I already have 2 nodes on another job, and now they're not, because it's only a 2-node cluster, there's no more available. So it's just going to sit here and wait. And then if I go in, let me just split these for a second. If I exit out of this one, then this one is now granted over here, right? As soon as I exit that previous allocation. Okay, now what can I actually do in this once I have that allocation? I can run jobs basically. So I can say srun, and then if I say just host name, for example, that's going to run the host name command on those 2 P5 nodes individually, right? Or if I do srun NVIDIA SMI to actually see the GPUs, you can see it actually prints everything out twice. So you see all the GPUs printed twice because it's grabbing the GPU info for both nodes. So basically, it's just a way to submit commands to those nodes once I have that allocation. And then the main way to actually submit a job, I'm going to go ahead and launch a job here, even though I'll come back to the details about how exactly it works in a few minutes. But I just want to get this launched because it takes a few minutes for the job to actually start up. So I'm going to go ahead and launch one of the Mixtral jobs using sbatch. And sbatch is probably the command you're going to use most often, actually. What it does is it basically combines that salloc and srun command together. And so what it will do is take all the instructions I've given it in an sbatch file, which are these up at the top where I've told it how many nodes, the job name. Exclusive means I get complete access to all those nodes. It is possible in SLURM, depending on the cluster settings, to get like a few CPU cores of each node. But in this case, especially with GPU machines, you pretty much always want exclusive access. So I'm telling it that here, and then I'm actually giving it the whole job to run. And I'll come back to this in a minute, but I want to start that now so it's running in the background. And then what you'll see is it also produces a log file. This is usually preferable if you're running a lot of long-running jobs. You want to make sure to have those log files for error reporting, for documentation. So usually sbatch is the way you want to do this. So with that, let me jump over quickly to, I'm going to open up another Jupyter lab here. And just to clarify, so I'm going to have 2 of these open. I use Jupyter Lab quite a lot. The light mode, that's running on my local machine. The dark mode is running on the cluster itself. So what I want to show here is the actual cluster setup. I'm just going to briefly go through that and talk through how I got that cluster that I just showed. And what this is in here. is we have so there's these basic cluster setup commands I've set up in here. This is a cluster after I've run that configuration. It takes about 10 minutes to set up, and then you just have a cluster running. And typically what you would do is you would have, like I said, you would have 32, 64 nodes, something like that, up into the hundreds. And you would have a bunch of different scientists working on it. And you can have different priorities for jobs. For example, maybe there's one senior scientist who gets to preempt everyone else and take over the cluster when they need to. You can customize all that to whatever your company needs. Then what I like to do for my actual development is get on that login node and start by creating usually a Conda environment with whatever, PyTorch version, Hugging Face, all that kind of stuff that I need. And then I'll usually just start it out in a notebook, where what I'm doing is basically just creating a mini version of that model that I'm working on. So in this case, I have this notebook called Scratch. That's just where I'm playing around. And what I've done in here is I've actually created, let me scroll down here, a miniature Mixtral model. You can see here, yes, the tokenizer and the model type should be somewhere in here. Are Mixtral 8x7. But what I've done is I've actually modified this model to be smaller than normal. So I've made it such that it's just 2 layers and the hidden size is much smaller. So it's not actually an 8x7 anymore. It's an 8 by like 0.003 is like it's basically a tiny version of a Mixtral model. And the idea is it's doing the exact same thing, but I want to be able to run it on my little GPU just to set up like my data loader and make sure it actually trains a little bit correctly. And then I'll just crank up those numbers and launch it on the bigger cluster. And so this notebook allows me here, so for example, to actually create my data loader. I think it's really important. I think this is something that gets skipped over a lot. It's really important to understand like what your data loader is doing. Right. So in this case, I've actually gone through and just made sure that my data loader is actually loading and then converting it back into text just to make sure it looks how I expect. Because what I've seen a lot of people do is they'll, try to put their data into some existing data loader and it just garbles all the output and then the model trains on nonsense. So this is just making sure it actually looks how I expect. And then from that, scroll down past all this text. So I'll go over what this is in just a second. This is actually for the distributed training. From that, I'll actually create, like I said, a miniature version of the model, and then actually run a little training loop, right? And so you can see it's actually not training, and the loss is actually going down as we would expect. It'll bounce around a bit, but it is actually training a little bit on that tiny that single GPU. And in fact, I can actually come over here and check if I run NVIDIA SMI. This is my local machine, my one A10 GPU, my login node. All right, so I have that model working. Now the trick is actually getting that up to that like 2, or in this case we're running 2 node, but normally you would run as high as like 128 or 256 nodes. But it's actually all the same procedure, no matter how large you go. In this case, we're going to use a distribution technique called fully sharded data parallel. And this is really kind of the simplest data parallelism you can do. And for a model this size, the idea is we're going to shard the model across a bunch of different GPUs to reduce the memory consumption. And as needed, those GPUs are going to pass the layers of the model back and forth during training. And that just makes it so that, we have a model that won't fit on a single GPU, but we can spread it across, typically 8 or 16 GPUs, and you just have multiple copies of that across the cluster. And in order to do that, we have to tell it what part of the model to actually split across the GPUs. In this case, what I'm doing is I'm grabbing that actual Mixtral transformer layer, and I'm splitting that across the GPUs. Right. So the reason I have it commented out in the notebook is you don't want to do that for a single GPU. It doesn't really make sense. But if I go over to my training script, this one, this is actually the same content that I had in the notebook. I've just now kind of expanded out, added a scheduler, and then added that FSDP segment that I had commented out earlier. So that's this in here. And then to run that, that's actually what I launched a few minutes ago. You really want to have a consistent environment that you can port across clusters and share with other coworkers, everything. And so for that, typically you'll go to Docker and enroute. I'd say that's kind of the standard way to work on this at this point. And what Docker is, just a standard Docker container. It creates an isolated file system. Enroute is basically a way to convert a Docker container into a almost kind of like Conda-like environment, but that's very popular for SLURM clusters. It was developed by NVIDIA a few years ago. So what you'll do is you create a Docker container, convert it to that enroute format. There's examples of those in the repo that I posted earlier. And then you use a tool called Pixis. Throwing out a lot of terms here, but Pixis is actually the tool to launch an enroute job on SLURM. And so that's what this sbatch file is doing. We're setting our number of nodes. We're setting our paths for everything to get mounted in the enroute environment. And then we're pointing it to, in this case, I'm using a version of the NVIDIA Nemo container that I've made into the squash file. That's the enroute format. And then just passing it all my standard torch run arguments. This is actually really nice. This is a good setup I'd recommend using for pretty much all your SLURM jobs, by just giving it the nproc per node and then using this rendezvous address and setting to a host name. Basically, no matter what size you go to in your SLURM cluster, it will use the SLURM environment variables then to automatically set your torch run arguments for all the distribution. So whether you run 2 nodes or 2,000 nodes, it will set it up for you. And then finally, I just have the training arguments. These are just modified from what I had in my notebook, just making the model bigger. And then finally, the srun command actually launches the training job. And I'm telling it to go to that train.py file I have here, pass in those training arguments. And then we can actually go now look at the log files and see what you'll see. Let me also point out here, you'll see a ton of this net OFI output. That's intentional. A lot of people get worried when they see all the output as like error messages or something. This is actually setting up EFA, the super fast connection between all the GPUs in the cluster. And I always set it to print out all of that info because it's really useful for debugging if something goes wrong. But it does print out a whole bunch of stuff before the job starts. So let me just scroll past all of that. Okay, and you can see down here, it's actually, so now it's actually training. And this should be going, let's see, it just updated a second ago. Yeah, so it's in the middle of training right now. It's running as expected. And so what it's doing is it's got that model split across 2 P5 machines, so 16 H100 GPUs. And it's just passing those mixture of experts layers back and forth between the GPUs to train the model. So that's the main workflow for developing that model. I'll go ahead and pause there. If we have more time, I can quickly show the Llama 2 model, but I want to see if there's any questions first of all.
Great stuff, Ben. Yeah, really well laid out. And okay, yeah, we have a good question here about, can you create heterogeneous clusters and I guess, can SLURM manage A100s and H100s? I think the person's probably asking about partitions, right? SLURM partitions, maybe. Yep.
Yeah, you could absolutely do that. So
are we training the model from scratch in this example? And can you comment about fine tuning if you were interested in fine tuning this Mixtral model?
So we are training the model from scratch in this case. We're training from just completely random weights. In this case, I'm using the C4 data set, the colossal common crawl, or the clean colossal common crawl. And you can definitely fine tune as well. It's really, you can just use the same procedure for fine tuning. You would just load the weights typically from Hugging Face and then load your own data into it. You could also, use a LoRa adapter, but you probably don't need, if you're using a LoRa adapter, you might just run like a single node job in that case. Which can still be useful for SLURM just for managing those jobs to different, the different machines. Also, there's a question about the GUI for monitoring the resources. I completely forgot about that. Thank you for mentioning it. There is a couple of tools I want to mention on Jupyter. One is that we have TensorBoard. I don't actually have a TensorBoard output running, so it's not going to do anything right now. The other, though, is this SLURM job monitor. And this was something, I think it was developed by Lawrence Livermore, that basically just hooks into your SLURM control daemon and can show what jobs you have running. You can, kill jobs or create new jobs from here. So like submit a new job. This was really useful for me over the weekend because you can see I'm at job 1051. I actually ran 1,000 jobs on here. And I needed to be able to see like what jobs were completing when. And so I could put them all on here and then manage them from this interface.
Sweet. Okay, and I pasted the C4 data set. I also pasted a link to the Jupyter Lab SLURM extension. Antje's going to talk about instruction fine-tuning in a bit, and yeah, Antje, maybe you can mention the LoRa, well, I think we're actually going to cover Heft and LoRa next month to dive deeper into how to do it on a single GPU or a single instance like Ben mentioned. And okay, and I guess so FSDP, and then so this is the Mixtral example. You will at some point add this example to the GitHub repo. It's not there right now, right? Just the Llama 2 example is there.
Right. The Llama 2 example is there. This is we're cleaning this up. We'll get that added in shortly. If you want to play around with it before then, you can let me know. I can send you the modifications. It's really just a matter of giving it the correct layer for FSDP. That's really the only major change.
How did you decide on that on just those layers for the FSDP?
Yeah, so typically you'll use the it's the transformer, the dense matrices of the transformer that take up the vast majority of the memory. And so by splitting across those, that actually saves the most memory usage on each GPU. And given that we have a P5s with RDMA, you can shift those back and forth between GPUs very quickly.
Gotcha. Yeah, Ben's pointing out the fact that the new P5 instance type that we have, the P548XL that has the H100s also has improved bandwidth between those GPUs. I think it's, what is it, 3.2 terabit between there? Yeah, versus previous generation, which was, I think, 800 gigabit or something like that, right?
Yeah, it's 3.2 terabit, and then the GPU direct RDMA that lets them basically, the GPUs anywhere in a cluster can basically grab from within the memory directly of another GPU without having to go through a CPU or anything as well.
Oh, gotcha.
That makes it
okay.
super fast for moving those around. Yeah.
Gotcha. The 3.2 terabit is between the instances if I have multiple P5s. Gotcha.
Yes.
And then but there's higher okay, right. There's like RDMA, and the P5 has RDMA, it's bidirectional, right? Versus the P4. Okay. So that's
Yeah,
okay.
Right. Yeah. Cool.
Awesome.
Sorry, I think we have a few more questions. I'll try to answer those in the chat because I know we're kind of running short on time here.
Recommended way to manage config to GitHub. Okay, yeah. And so how is this different from Zookeeper, any competitor to SLURM? What else do you see folks use? Yeah.
So Zookeeper, I'll be honest, I'm not super familiar with Zookeeper. I've heard it mentioned. You know, but I haven't really played around with it. I mean, SLURM, in my experience, SLURM is just the most straightforward. It's kind of has the fewest features, but it's just the easiest to get up and running on. And that's one of the reasons it's very popular for HPC systems, is it, you know, it's customizable and it does what people need. The other is, okay, the other question here was configurations for submitted jobs in SLURM. I usually just keep them on GitHub. I mean, it's just kind of whatever is easiest for you. But I would say I just set up a GitHub repo, and then just keep all my configurations there.
Yeah, Ben. Yeah, how about the question? Any gotchas on CUDA compatibility? I just was on a call with you yesterday with a customer dealing with this.
Many gotchas on that. So basically, you want to run everything in environments. You know, you have you know, when you set up a cluster in HyperPod, it's going to set up with the same AMI on all machines. And so it's going to have the same CUDA version everywhere. But you want to make sure to run everything in either a Conda or like a Docker in-root environment where you have all that stuff fixed. You know, one of the common mistakes I saw, I've seen with a number of people that are kind of new to these clusters, is they'll just set up SSH to each node and then like go in and manually set up environment and manually like set up packages on each node. Don't do that, because you'll end up with you know, stuff directly on the AMI that is different between nodes, and that will create all kinds of compatibility issues. So what I typically do is just go to the FSX volume that's shared across all the nodes and create like a single Conda or Docker there, that everything's accessing the same thing, everyone's getting exactly the same version.
Okay, and I know Antje has a hard stop here in a bit. So Ben, thank you so much, man. I think this is awesome, and
yeah,
can't wait to work with you more, man.
Cool. Thanks, everyone.
Cool. Antje, are you ready?
Yes, let me take over the screen share here.
We will likely go a bit long for my portion of the talk, but we'll continue to record. So, and yeah, Ben, feel free to drop whenever you need to drop. Thank you.
Thank you, Ben. All right. As Chris mentioned in the beginning of the meetup today, every month we're also covering 1-2 chapters from our book. So today we're talking about instruction fine-tuning and continued pre-training that falls here into this bucket of, once you have the base foundation model, either you pre-trained it or you used one, how can you adapt and align the model further to your specific use case and data sets as well? So let me jump over here, and I'm just going to basically walk you through the chapter here of our book. So this is, I think it is chapter 4 when we talk about the fine-tuning. And to start with, when you think about it, there are a lot of foundation models out there. I think 2023 was really the year, definitely of LLMs, but so many models that came out, really amazing. If you notice, like if you take a base foundation model and you ask it a question, it might not always respond in a way you like, right? If you take just the base model and say, hey, can you summarize the following text? Can you do something? So you're basically asking it a question and you expect it to follow the instruction. What will happen if it's not instruction fine-tuned is that it tries to just complete whatever you put in as the prompt, right? So it might just continue a discussion rather than summarizing what you put in, etc. So to change that behavior, to adapt the model to actually follow your instructions, there is a step that you would do that's called instruction fine-tuning. And the good news is there are already a lot of models out there that already have that step done. So for example, you will notice if it's called the -instruct model or a -chat model. Prominent examples here, for example, Llama 2 chat. So that one is already instruction fine-tuned to follow questions you ask it. Falcon chat is another example, or Flanty5, which doesn't have the chat or instruct in the name, but this one is also an instruction fine-tuned model. So there are already a couple of those out there, but in case you have a need to perform this yourself, I'll walk you here just briefly through the steps needed. The first step is you would have to get a data set together, so an instruction data set. And again, if you want to do this specific for your use case, you would basically provide and put together this data set. If you just want to play around with the models, there are also public open data sets you can use to just get a grip, get an understanding how this works. Or if you just generally want to fine tune that, you can use those examples. The good news is you don't need too many of them, right? In contrast to the pre-training phase of the model, where you need really kind of millions of documents, sometimes billions of tokens, the fine-tuning step is literally can work with less data. So we called out here like 500 to 1,000 examples, sometimes maybe more, but it's a different dimension compared to the pre-training. All right, so if we look at the data set, one thing that's important is that we do train the model, fine-tune the model on multiple tasks. Unless your use case is very specific, let's say you just want to fine-tune the model to summarize something, or you just want to fine-tune it to rate a review. Like if you only have one use case, it's fine. But generally, we want to keep the model's ability to generalize and to be good at different tasks. So what happens if you only train it on one specific task, like summarize the following thing? There is an phenomenon that's called catastrophic forgetting. And that means that the model gets really, really good at the task you're training at, but it probably gets worse at all the other tasks, right? So that's something usually we want to avoid. So to avoid this, again, we're doing a data set that goes through multiple tasks. And you can see this here, for example, summarization tasks, rate a review, translate into Python code, identify places. So to keep really kind of the generalization power of the model. And let's see, here's an example of the data set that the T5 model was instruction fine-tuned on. It's called FLAN, the FLAN instruction data set. And you can see this one is really large. So this one has over 473 different data sets across 146 task categories. So this is a really powerful data set. Again, if you're building that for your specific use case, it might be smaller than that. But those here are examples like for the large models that have been instruction fine-tuned. And you can see it's across different tasks, whether it's just, reasoning tasks, whether it's following natural instructions, etc. All right, in our book and also in the code examples, Chris put in the GitHub repo link where you can find all the notebooks, all the code examples. We actually used here one data set, the Samsung data set as a demo use case, which contains 16,000 conversations and human-created summaries. So in this case, we're showing you how to walk through this for the example of summaries. Here's just a quick peek into the data set. So you can see here is a dialogue across different topics, and then there is a summary that humans created. Now, when you have your data set, and again, this might be specific to your application, to your use case, you need to prepare the data for the model training, for the model fine-tuning. And you do that with the help of a prompt template, for example. Prompt templates help you to convert those text files that you collected and put it in a format to then fine-tune the model. So here you can see that we're going to run through this text data set, and here's the dialogue. So that's the field from the data set above that you saw. And then we do a variation of the instructions. So here we do, for example, briefly summarize the dialogue, and then we'll put in the summary. Or here's a dialogue, write a short summary. What is the summary of this dialogue? So we're kind of showing variations of the same question, right? As in the world, like people would ask different questions for the same task, probably. All right, and there's also a collection of prompt templates available out there if you're curious, or pretty easy to build one yourself as well. Okay, so once we have done that, and here we also do have the code example. So again, in the GitHub repo, you find the full code. Here in the book, we do have an example how you can build your own prompt template and then basically transform your data into the training data set. Then the actual step of instruction fine-tuning is pretty much a supervised learning step, right? So I'll just use here this figure to explain. I just talked through how you're going to start creating your instruction data set for the fine-tuning, and then you do a traditional supervised learning step here. So you're taking the LLM and you train it with a new data set, meaning you generate a response for a given prompt, and then you calculate the difference from that human baseline that's in the data set, and you update the model weights in backpropagation. And this is basically how you fine-tune on the instructions. We do have a couple of examples here. So where can you do this? You can fine-tune models using Amazon SageMaker Studio, for example. We do have, again, the full code in here, how you can do that. You can also use SageMaker Jumpstart. So that's a very easy way to fine-tune models on AWS with a lot of like code examples already there. So very easy to just get started doing it. Versus in Amazon SageMaker, you also have like the freedom if you want to customize more and bring your own code. But again, Jumpstart is a very easy way to get started. And then also Amazon Bedrock, our new service, does have the capability to fine-tune models. All right, we do have another example in here as well for Hugging Face models. Feel free to check that out. And then the last part here I want to touch on before I hand over to Chris for the discussion, fine-tuning versus continued pre-training, what's the difference, and how do I do both, is on the evaluation. And that's a big question, right? Like, how do I evaluate the models? And there are a lot of different metrics out there. And if I'm coming more from the traditional sense of, hey, I'm training my model on summarization tasks, you could use metrics such as SLURM, right? But in the sense of generative AI, what we often need to do is to evaluate the model more holistically, because that's not the only task, right? You might want to check how good the model performs still on reasoning, especially if it's across the different use cases and tasks. And there's a couple of benchmarks you can use. So there's the Holistic Evaluation of Language Models, HELM, and there's also the Massive Multitask Language Understanding, MMLU. And they can definitely help to provide a first baseline, but then it's also really important that, again, for your specific use case, you define the metrics that are most impactful for you and also evaluate on them. But again, it's going to be a mix. So you have some more traditional machine learning evaluation metrics, also like accuracy, of course, root mean squared error, and then also kind of the more benchmark oriented that check the model performance across a larger variety of tasks. We do have code examples in the GitHub repo for this one too. And just here to finish off, quick summary. This one was really kind of the instruction fine-tuning step. So again, if you're working from a base foundation model and you want to teach it and align it to follow instructions, that's the part. And in next month, we're also going to talk about the parameter efficient fine-tuning. So this is a step you can do where you bring in your own data and very efficiently fine-tune the model. And it's able to focus on really kind of the efficiency parts. And Chris mentioned it earlier as well. For example, as the models get larger, traditional fine-tuning updates all of the parameters. But with those large models, you need more efficient methods that are able to reduce the memory footprint, but still get to the result of like, aligning the model. So PEFT is a really, really popular method to do that, which we'll touch on in next month meetup. And now I'll hand over to Chris, who will walk you through another technique, which is called continued pre-training. And the number one question, what's the difference there, and when to use which? And with that, Chris, over to you.
Cool. Let me get my fancy sharing going. Can you see my screen? Oh, looks like I shared the blank screen.
Just a bunch of videos, windows here.
Yep.
Yep, now we're in the browser.
And you see me down on the bottom right there? That's so cool.
I know.
Yeah, I love that feature. Okay. All right, folks, and let's see, this particular repo here, yeah, Antje, I think there's a question there remaining that I didn't get to right at the very end from George. The specific, so this is the notebook. I'm going to walk through some code. I'm going to first kind of talk a little bit about what continued pre-training is versus instruction fine-tuning. And yeah, all of this code is in the repo that I pasted here. So we are going to use continued pre-training with like Amazon Bedrock, okay? And specifically, we're going to use one of the Amazon Titan models, which is one of our large language models that we offer behind an API. And I'm going to demonstrate how to take a pre-trained model. In this case, it's the Amazon Titan model. And we're going to continue to feed in more and more documents, you know, and to introduce more knowledge into this particular model. And so this is really helpful if I want to, let's say I have my own set of PDFs or, you know, my own intranet or my own HR documents or, you know, customer data, whatever that I want to feed in. And this, and so the model, the weights of the model will actually change, and the like output here actually will be a custom model from Amazon Bedrock. That's a customized version of the Titan model that's available behind a really clean API call. And so I'm going to go through all those steps here throughout this notebook. And I think this will only be about 5 minutes or so. So maybe, you know, 5 or 6 minutes. We're already 5 minutes over, but we'll continue to record and then post this afterward. So the steps that we're going to do, we're going to just test the base model right off the bat, and you know, see how Titan does on, you know, knowledge that it probably doesn't have. And then we're going to take a PDF. The PDF that we're going to use is actually our book PDF. We're going to submit it to Bedrock to then customize a Titan model. And then we're going to provision that model to actually take requests, you know, take prompts, and then give us some completion, some, you know, outputs back. All right, so here we're just going to set up Bedrock. And now continued pre-training, just to be clear, is not specific to Bedrock. Continued pre-training is sometimes called domain adaptation. The main difference here is that we don't have to go through that rigid prompt like template setup, right? Where I give it a clear instruction, and you know, I have to format it all nicely and everything. I can just like literally give it raw PDFs. I can give this type model raw PDFs or raw, you know, Word docs, and it will continue to pre-train. Basically, that's where the term continued pre-training comes from. So let's just test this right off the bat and see, okay, describe the book Generative AI on AWS by O'Reilly. Now, the Titan model does not know about this book. And I know it doesn't know about this book because when I built this example, it was for reInvent, and our book was not even public yet. It came out during reInvent. And so I did the same exact demo on stage at reInvent, and it was pretty fun because you know, this model obviously didn't know anything about it. And let's see what it says. So, you know, as most of these generative models do, they like to just answer things. Now, you know, I could have probably told this model, if it's not sure about this book, then, you know, it's okay not to answer, just say you don't know. But I didn't say that. I was curious what it actually would say. And, you know, here we see it's doing its best and, you know, doing a little bit of like hallucinating here, as we know these models tend to do if they're not instructed to, you know, just say no if they're not confident. And so here we see specifically this is calling out SageMaker and transcribe recognition. Now, I would have expected this if it if it knew about our book, it would actually be sort of using phrases from our book. It would probably talk about Amazon Bedrock, which we obviously cover in the book, and I don't see any mention of that. And so this is before the pre-training, just to be clear. Now, we're going to load the PDF. That's the PDF for the book. We're going to chunk it up. I'm actually going to use some libraries that I'm familiar with from the LangChain project that I know can do, PDF loading and can chunk the PDF up into, chunks that the model can actually accept. And so because I know that this model has a 4096 input context window for the number of tokens, I'm going to roughly, say there's maybe 6 characters per token, just a rough estimate, maybe 24,000. I'm going to round down and say, each chunk of data that the model sees will be about 20,000 of these characters. That's the character limit. Now, it just so happens that that turns out to be about 1 page per chunk. And so we see here that the book is roughly 300 pages, and I got roughly 305 rows of data. So what I'm doing here is I'm actually converting the PDF into a bunch of JSON lines. And JSON line format is really just JSON. It's just each line in the JSON document, or in the data set, is a complete full JSON document. So it just gives me a way to pass in multiple JSON documents. And I can look at these with pandas. Pandas, all you have to do is do read JSON and say lines equals true, and it understands this format. Okay, so what I've done is I've taken a raw PDF, I've chunked it up into roughly 1 page per chunk, and this works out really well because about 4096 tokens is what this model can handle, and I'm just going to feed it in. So the way I feed it into Bedrock is I have to upload it to S3, and then I'm going to create what's called a custom model. And I'm going to launch a model customization job within Bedrock. I'm going to tell it I want to do continued pre-training. If I was doing it the way that Antje showed, I would have specified fine_tuning here. But because I'm doing the sort of unstructured, I'm just passing in a bunch of JSON lines, basically the PDF, I'm going to say continued pre-training. I'm going to give it some hyperparameters. I have to be honest with you, I wasn't sure of these hyperparameters at first. This took a bit of back and forth and a bit of sort of informal hyperparameter tuning. I also had the luxury of being able to rely on folks like Ben Snyder, who you just saw earlier in the session, and the other like applied scientists that are part of Bedrock. They actually helped me figure out the best the batch size, the learning rate, and the number of epochs. Here, I give it the training data S3 location, which was the JSON lines that I did before. And then all I do here is I wait for this job to complete. I then deploy the model here. There's a bit of a goofy API here. I don't particularly like the name of this API, but that's what Bedrock folks chose, the service team chose, and it's called provision model throughput. I just call them endpoints, but this has now deployed my custom continued pre-trained model that now knows about our book. And so let's just do this again real quick. Let's just compare. This should be the same as it was before. So this is without the custom model. This is just the straight up model. This really, I just copied and pasted this from up above. Now let's look at our custom pre-trained model. And here we see that the new description now, when I say for the prompt, here's the prompt here, describe the book Generative AI. So now the model knows about this book. And here I see the stuff that it's outputting actually follows the style that we actually use in our book. So we talk about data prep, we talk about the build, train, and the eval cycle for these models. It's using, terms from our book as well too. It talks about Bedrock here, and also talks about, plenty of code examples. And so what's cool here is that because I was one of the authors on this book, I know that, this was the style that we used in the book. So this is a pretty good summary of the book. And then, of course, I just clean up the provisioned model so that I don't incur extra costs. And all of this code is right here for you. So let me see. Antje, any questions?
Not right now.
Okay, it looks like, yes. And we're going to, yeah, so the recording will be available. Let me just type it in here real quick. And so, yeah, Antje, next week we have our other co-author, Shelby Eigenbrod, and she'll be talking about PEFT. Is that right?
That's right. And there's one question coming in, the difference between pre-training and RAG.
Oh, yeah. Looks like here, YouTube. So we'll post the recording there. Right. Yeah, pre-training and really fine-tuning. Well, you're adding in new knowledge to the model itself, and so there's always this kind of back and forth, and really, like, you can use pre-training and RAG. So, for example, you would use pre-training to introduce new concepts, maybe that are specific to your domain, right? Yes, I remember this example a couple of years ago that I was at a conference. LinkedIn was talking about how the standard models that were out at the time, this was a couple of years ago, didn't know about linked or didn't have, really crisp knowledge of like what a job and what like a resume and what a connection and things that were specific to LinkedIn's domain. Like those were not really inherent. Now these days, yeah, these models are so powerful that they do know, like these kind of concepts, but you would pre-train to introduce sort of fundamental concepts into your model, and then you would use RAG in combination with the pre-trained model to actually pull in like the latest information, today's news, yeah, today's things from your business. Okay, and yeah, to pre-train this model, I believe only costs, I think it costs less than $1 to pre-train it on this entire book. And then I believe it took maybe, I think it took maybe about 20 minutes or so. But I did use a pretty powerful GPU to do the training behind the scenes. But actually, it was all managed by Bedrock, and so it's a managed service, and there's time, but you only pay for the time that's needed to actually do the training, and then do the model serving as well too. Oh, and the events will be next month, not next week, and it's just part of the same series. So it'll be the third. What is this Monday? The third Monday of every month. Okay. Yeah, GitHub repo, I'll share again here. Oops. Okay, and when's the next event, Antje? The March, oh, looks like Antje had to drop. Yeah, she had a hard stop. Yeah, it's part of the series. It's the third Monday, so I think March 18th sounds about right. Yeah, quick note on privacy. So just know that when I did create this custom model, none of this data is used by AWS to improve any of our models, right? So, and yeah, so I should be very crisp here. I, as a user, have provided my PDF and to AWS Bedrock to train this model. However, the model is custom to me and is not shared by any other customer. It's not shared with AWS. This is specific to, so all of this data stays private to your account. Excellent. Okay, everyone. And yeah, thanks again, Ben. You are awesome, and always look forward to working with you, and we'll see you next month, everyone. Thank you.